Hi guys, this is Mr. Forrest here. This is our first video lesson of the year. This is on section 111 in our textbook. This section is on rational exponents. So in order to access this, you're going to need to get out your textbook. And this first part of our notes is actually not something that is in our textbook. Notes that I took from a note sheet I've had in the past, and I didn't think it was worth it to print off the whole thing. So this is the part that I'd like for you guys to write down. So find a blank page near page 11. This way we can keep everything together. Our lesson today is on rational exponents. We have an example of what we're looking at here at the top. Okay, so notice this form we have on the left. This is using a radical or a root. Then this form we have on the right is containing a rational exponent. We see the definition of a rational exponent at the bottom. That's just an exponent that is a fraction. Okay, so these are equal to each other. They're equivalencies. There are different ways of writing this out. So notice we have a radical or a root here, as well as an exponent for this left-hand side. So part of our skill today is going to be going from this radical form to this rational exponents form, or vice versa. Okay, so that's the first thing we're going to do. First, we got to get some vocab down. So the base, that's the quantity that's being raised to a power. So like this example on the right here, A would be acting as our base. A root, that's the inverse of a power and exponent. So examples of roots, that would be like square rooting a number, cube rooting a number, right? Those are roots. It's the opposite of raising it to that power. So taking the square root is the inverse of squaring a number, right? Those are inverses of each other. And then review that a power and exponent is the number of times the base is being multiplied by itself. Okay, so something like 2 to the third power, right? Our base is 2, our exponent is 3. That's the same thing as saying 2 times 2 times 2, right? Our base is being repeatedly multiplied 3 times because our exponent was a 3. Okay, so let's go through our couple skills for today. So first, rewriting. Okay, so we're going from this radical form to a rational exponent. Okay, so the way we want to think about this is our root is what's going to come and carry down to the bottom. So this 3 is going to come below the 5. We'd say x the 5 over 3 power. It's really that simple. There's nothing else we can do there. Okay, so here the 7 comes to the bottom, x 2 over 7 power. This one right here, x to the 6 over 2 power. Now here, this one we can't simplify a little further because our exponent is now 6 over 2. Well, that can be simplified. 6 divided by 2 is just 3. That's the same thing as x to the third. Okay. Since our directions just say rewrite each expression using a rational exponent here, as our base becomes a number, that's not really going to change things much. Okay, so the 7 can come to the bottom, 3 to the 2 over 7 power. It just said rewrite, so that would be all we would do. It said to evaluate. The word evaluate means get your answer down to just a number. That would be different directions. We could actually use the calculator to find that. Okay, so same thing here. 5 to the 8 over 3 power. Last one here, 2 to the 8 over 4 power. Now, technically it said just leave it with a rational exponent. Personally, if I looked at that, I just can't leave it like that, right? 8 divided by 4, that's 2. 2 squared, 4. Okay. Now let's get into the next skill. So actually evaluating using a calculator. Okay, so this is where we're just practicing inputting these into a calculator. This isn't something where you could just do 5 to the 6 over 4 power in your head. Okay, so this is where a calculator comes in handy. Oh, sorry guys. 1 sec. All right. So we were going to put in 5 to the 6 over 4 power. All we'd have to do is put in 5, caret key. Now, if we had this calculator right here, which is technically an older model, when we hit this caret key, notice there's no parentheses or anything. There's no raising of to an exponent. So if I'm trying to put in an exponent of 6 over 4, I can't just put 6 divided by 4. I'd have to put parentheses 6 divided by 4. If you have a newer TI calculator, the newest versions actually raise, instead of putting that caret key, it actually raises and looks like an exponent. Then you wouldn't need to do those parentheses. But if you have a model like this, you'll have to put parentheses around the exponent. Okay, so we end up getting 11.1. Okay, so it'll be the same deal for these other ones. Let's try one with a root in here. So it's going to change a little bit now. So you technically could put this into our calculator like this, but it gets a lot messier. My suggestion is going to be, let's rewrite this to a rational exponent first. So that become 9 to the 2 over 3 power. And now that's much easier to put into your calculator rather than trying to put in the third root of 9 squared. Okay, so now we put in 9, caret key, parentheses, 2 divided by 3. And we wind up getting 4.33 approximately. That's a good thing that we're talking about. So here we made approximations. So I'm going to use that squiggly equal sign saying it's approximately 4.33 because we did round there. Okay. These ones I'll leave examples like this in our. Okay, so I just want to do some intro examples. Our book only has a couple examples in there. So now let's actually get into specific pages in our textbook. So page 11, how can the expression 3 to the 6 over 5 power be written using roots and powers? Okay, so we have this rational exponent. We have 3 to the 6 over 5. If we were going to change that using a root and a power, remember, I have to take the bottom piece, in this case the 5, and that part is going to become the root. Okay, so I would have the 5th root of 3 to the 6th power. All right, that would be how you would change it. So that number on the bottom becomes the root. Number on the bottom of our rational exponent becomes the root. Yeah, okay. See another one. So page 12. Now we have a base that's just a letter, a variable. That's fine. Okay, so I'll write this out a little bigger. Okay, so we have 8th root of a to the c power. Okay. So if we were just kind of working on our vocab here, the base, that would be a. Okay, that's what's being repeated. Our root, well, we have the 8th root. And then our power currently is c. Okay. So we're going to rewrite this using a rational exponent. Remember, the root needs to come to the bottom. Okay. So that would just be a to the c over 8 power. Okay, it's just that simple. There's nothing else to do. All it's saying is to rewrite. Okay. A couple other skills we have in here. Example 4. Well, this is just another evaluating question like what we did before we hopped in our book. So why don't you guys try to do this one right now? And then you can input your answer into the question field. Okay, let's check our answer. We should have done 4 to the 10 over 8 power, right? Taking our root, bringing that down. We put in 4 caret key parentheses 10 divided by 8, which I got approximately 5.65. Okay. One more problem type for today. Example 5, it says a town's population is decreasing. Population in the year 2000 was 4,000. The population t years after 2000 can be found by using this function. Right? This is function notation. Hopefully remember that from last year. F of t would be how we'd say that aloud. So it says f of t equals 4,000 times 0.96 to the t power. Okay, so that's an exponential function, right? That's what we learned a lot about last year. It says, what was the town's approximate population 2.5 years after the year 2000? Okay, so remember, this is a function where it's saying our first variable t is the time after the number of years that have passed since 2000. And it's going to spit out for us f of t, which it said f of t represented the population of the town. Okay, So if it's saying 2.5 years after the year 2000, then find f of 2.5, right? Because we're going 2.5 years later than 2000. Our input would be 2.5. Okay, so f of 2.5 equals 4,000 times 0.96 to the power. Well, now it's no longer t, it's to the 2.5 power. Okay, and then we can practice inputting this in our calculator. Okay, so if we were going to input this, we would put in 4,000 times 0.96 caret key 2.5. So it's an approximation, right? So what's the approximate population? So we have 3,611.9. Well, we're dealing with population, number of people, so we'd want to round to the nearest whole number. With 0.9, we could round up one. Okay, so we're looking at approximately 36.12. So 3,612 people. Talking about population. Okay. You'll see a couple like that. That's kind of a review from last year. But the biggest topic for today is going to be those rational exponents in there. Okay. Let's skip ahead to our homework for tonight. Okay, so our homework for tonight, we have page 15 to 16, numbers 1 through 10. Okay, so do this straight in your textbook. Remember, in your math textbook, if you go to the back, you can take a look at there's answers in there. It doesn't have the work, okay, but that can help you as a guide. And this is what we will start with first thing in class tomorrow, is discussing this homework. Okay, so as always, reach out if you're having any questions for me.